Hello, I'm JW, and this time we have an RCD socket to have a look at. Just comes in this white box, and this is actually a UK one rather than that Flowerion one I had a look at a couple of months ago. And the information that comes with this suggests that there could be a couple of problems here. First of which is that it may trip with no load. Obviously that's not supposed to happen. And the second point is that when it does trip, there is a spark or arc visible around one of the buttons. So we'll have a look at that, see if we can reproduce the problem, and also have a look inside to see how it's constructed. Now here's the item here. It's comes in a fairly generic box. There's no specific brand name on it, and there's no specific brand name on the item itself either. So it's probably one of these that's made in some factory in China or wherever, and then sold under a whole different number of brands and different names. So metal clad with its own box supplied with it. Just the usual twin outlet there, and a pretty typical arrangement here on the front with the test button, which should of course switch the thing off, and then the reset button to switch it on again. And first thing here is the reset button there. It is a rather strange angle, so it's already sort of gone a bit wonky, as it were, so that's not a very good start. So let's open it up and see what it's like inside. This sort of thing would typically be used if you've got a circuit that doesn't have an RCD on it, and therefore you can just add the socket, and then the RCD protection is built in. Pretty much all socket outlets, certainly in the UK now, require an RCD protection either in the socket or on the distribution board, so a reasonable thing. So back box is just say pressed steel with the earth terminal down at the bottom, fixing holes on the two threaded lugs there, and then you've got these sort of knockout sections, and yeah, they appear to be the type where it's actually welded on afterwards, so punched and then just tack welded at the side. Yeah, there are some gaps there actually, so you wouldn't want to use this in a damp environment, because of course any water or whatever falls on the top of this and it's going to go straight through those gaps there, but anyway, it's probably not designed for that anyhow. So there's the back of the device, basically all encased in single plastic, line and neutral terminals there, and the earth at the top here. That also goes to this metal strip going to the holes or where the screws would go in. There's this very thin green wire here, which is just tacked onto there, and rating on the back 13 amps, 220 or 250 volts, and BS7288-1990, which is the standard for RCD sockets. The terminals look reasonable size. They've got reasonable size screws in those, and we should be able to open it as well because it's got these just three little screws there, which are this sort of sealing paint or whatever over them, which of course we should be able to open. So I don't like this very, very thin wire here. That's presumably just a reference to the earth here. That seems a bit of a shoddy way of doing it, particularly buying on this is going to be in the box here with other wiring, and these are going to be considerably larger, and there's a good chance of that becoming damaged, so they could have done that rather better by possibly connecting it behind this plastic moulding. But anyway, that's what we have, so I think we'll just power this up and see if it does actually work, what sort of readings we can get from that. Now I've just wired the socket here, just a bit of flex to the power supply at the back here, and we'll use the fluke tester here, which I've shown in another video. And first of all, we'll just check that it does actually work. Now, this is a passive RCD, as it says on the front, and as it also says on the front here, that means that when the power is disconnected, it does not trip. So as you see, the red bit in the middle is there, showing that it's actually on at the moment. The other kind of active, which means when there's a power failure, then it actually switches off, and when the power comes back on, of course the sockets are not powered. Generally you don't want that kind because they're fairly annoying, because it means every time there's a power failure or even a minor fluctuation, you've got to go around and reset them all manually. And if it happens to be providing power to equipment like a fridge or whatever, there's certainly the potential there for things to be left off for an extended time and destroy whatever's in it. So most of the ones for household use are the passive variety, so that when the power's switched back on again, the sockets remain in the state they were in before, so on usually. So anyway, we'll just connect the power up, and then we just test the testing button there, and hopefully it should switch off. So I'll just put the power on, and as expected it does click off, and we should be able to just to reset that again. Yeah, that's on off, so that's fine. That test function there works, but again it's very basic, of course. Right, we'll put the plug in from the tester, And we'll switch on, and this is actually the tripping time. And again, we'll do the set of tests as you would normally do if you'd just installed this. So we're going to use half the current to start with, and again we're going to do it at 0 and 180 degrees. So this should not trip, which it does not. 180, this should not trip either. That's fine. Now go for the ×1 setting, so this should trip because this is applying a test current of 30 milliamps there. So okay, that's 18.2, well that's fine. Well, that tripped, but it didn't actually record on the display, which is certainly interesting. Let's try that again. 17.6. Again, that's fine. And then we do the ×5. So that's applying a current of 150 milliamps and 7.8 milliseconds. Again, that's no problem. And 7.6 again, so that's fine. Now we'll just check the current that it actually trips at. This is a 30 milliamp RCD, so you would expect it to trip at or somewhat just below that value. Certainly not above 30, and certainly not any less than 15, although in reality you'd expect it to be into the high 20s to have some kind of reliability. So again, we'll try it at the 0 degrees to start with. 18, that does seem rather on the low side, but it's still within the specification, so say between 15 and 30. And again, we'll try on the 180. And that's 18 as well. So it's within specification, but 18 is certainly on the low side, because say it should not trip at 15, and then it should trip at somewhere between that and 30. And normally, say you'd want it to be at towards the 30 end. And of course, the lower it is, the more likely it is to trip in unwanted circumstances. But say 18 is within the expected range, just happens to be at the very bottom end of that range. Now, the other thing that was mentioned in the note was that a spark or arc was visible around the R or reset button when it was switching off. So I'll just zoom in there and have a look at that, and I'll trip the device and we'll see if we can actually see that. Now, the full lighting is on in here, so it may not be totally obvious, but anyway, let's see what we can see this time. Okay, well, it wasn't a great deal to see there, so let's just try that again. Now, I've just turned off the main lighting there, so I've only got the auxiliary lights on there, and we'll just try that tripping again, but so I'll turn the lighting right down. Right, well, as you saw there's quite an obvious spark in there. And bearing in mind there's no actual load on this socket, so you wouldn't expect there to be something that visible, unless I say there was a fairly substantial load on. So, for example, you put an electric fire in, of course you're going to be switching off a 3 kilowatt load or something, then of course you would expect there to be a spark visible. But all we've got plugged in here is just the tester, and I'm only using it on the ×5, which is only applying a current of 150 milliamps, so really very little in terms of mains power. So let's just try that again and see if we can just get that again on the camera there. So we'll just reset, connect up the power, and again I'll just turn down the lighting brightness there so we can just get a view of that. Right, well again there's certainly a definite spark in there, so that certainly requires a bit of investigation. So I think what we'll do now is just to disconnect all this stuff, and then we'll have a look inside. Right, so let's see what's inside, and I say, as we saw before, there's just these 3 screws here, so we should be able to open those reasonably easily, and then take the back cover off. Obviously there's some paint there to presumably prevent people opening it, or at least show that it has been opened. So we'll just go in there. Warranty void, of course, but then we weren't looking to claim on the warranty anyhow. So let's take those 3 screws out, and then the whole back piece appears to be just a single moulded part, so that should come off and reveal the insides. Again, those thread directly into the white plastic underneath, so obviously not a real problem though, because of course this is not something to be opened at all, never mind on a regular basis. So let's see what we have inside. Now the various springs and things are pinging apart. So this is inside, and got the two buttons there just with the spring loaded bits underneath, and the mechanical indicator there, red or white, for on and off. And a circuit board in the centre here with, again, just probably that single chip will do the entire thing, and a few other just capacitors and odd little bits and pieces. And we've got some wiring here going obviously to the line and neutral terminals there, which rather oddly is in the black and red colours, which certainly haven't been used in the UK for 10 years or so. But let's see if we can take any of this out and see what's underneath now. Okay, this appears just to pry out of there. So the circuit board there, we've just got the single 8-pin chip there. If there's any kind of marking on that, have a close look at that in a moment. And so just a few passive components there. Appears to be probably a transistor there, and say a few bits over this side as well. A couple of diodes and whatever that 4-pin item is there, possibly a bridge rectifier. The two buttons and the indicator. And we've got the wires here. These are the ones that go out to the two sockets there. So we've got the essentially the two wires just crimped down onto the same terminal. And of course, there's the neutral, and the same for the line as well in the red. And then these two here with the screw terminals are the incoming supply. And you see that actually goes through that small current transformer there. So both going through there. And of course, that's what's going to be used to sense the current imbalance, if there is any. And that green wire, which comes over from the actual earth point there, that comes straight over to the board here, and is actually just soldered on at that point. So, before any kind of pulling on that would very easily detach it. We've got several link wires on the board here, and again in that same green wire, although they seem to go across to the solenoid in the middle. Yeah, again, that's just going to be a simple coil of wire there. And of course, when energized, it's going to just move the plunger there to trip the mechanism by pressing on the plastic parts here to release the switch. Again, if the switch was pressed down, so you've got that plunger there which would latch in, and then pressing that will release it. So that's latched on, and then the solenoid just presses that to release it and of course disconnect the supply. Now I've got a spring here for the contacts. So again, that's the outgoing side, and the incoming side so it goes through here, and they've got these braids that go over to the moving contact. So it's in off position, and then of course it will close when you are pressing the switch down like that. So it's a double pole switch, and again that's what you would expect. And the contact gap is actually considerably larger than it needs to be. I think it's about 3mm is the requirement, so of course that's clearly several millimetres over that. Now there's nothing else on there particularly. We've just got the braids going over to the contacts on either side, a small capacitor there, and a couple of other components here. So we'll just go in and have a closer look at those and see if we can identify any of those components. So now a closer look at the actual circuit board here, and this is one side where it's got the test button things in the middle, and what we've got here then is just a couple of diodes there with the M7 marked on there. This 4-pin device is a bridge rectifier, as already guessed there. So again, we've got the positive and negative on this side, and then the mains or AC on that side there. And you can see these larger tracks here coming in from the main supply one to there, and of course the other one goes to the other pin underneath the device. And they actually continue over to these two pins here, and that's that metal oxide varissa or MOV on the back there, presumably for some sort of surge prevention or whatever. And a little resistor there as well. And over on this side here, again, the two pins there just go through, and again, it's another one of those MOV type devices there. So that's pretty much all we've got on this side. And then if we move over to the other side of the board, again, the switch and things in the centre. And over this side, we've got the 8-pin device there, which is going to be the sort of main chip that does everything. Just a few capacitors and resistors here. And then over here it's probably just going to be a transistor there, which is what's going to actually drive the solenoid or the coil that actually will trip the device. Now I'm just going to get the light on that chip to get the number from that. So there's the chip there, and it appears to be a CV4145AL. We've got a few of the numbers at the top and the bottom there, which should be just production codes or whatever, but 4145AL. I think that's pretty much the same, or if not very similar to the one in the Floria RCD socket I did a few months ago. And that component just to the side of the chip there is actually a resistor. If I just turn it, you see it does have the value on the top. It's just been put in at a really strange angle, so it looks like it's totally wrecked and destroyed. Also notice there's a whole load of flux residue and mess on the board there, which is pretty revolting. And a little 3-pin device there with a T169, which will be a transistor to drive the solenoid or coil that trips the device. And the rest of those just say a few capacitors there, and there's resistors there. And then the only device on the other side is from these 2 pins here. And just turn it over, it's just that little capacitor. Let's have a look at that. That's a Hua Hong brand capacitor. Never heard of it. And let's just check the value of that one. That is a 4.7 microfarad and 50 volts. So again, that's just the only other thing on the other side. And see that's pretty much the whole story. Just got the 2 buttons in the centre here, and of course goes through to the contacts on the back. And then all we've got here at the bottom is just the wires coming in from the 2 line and neutral wires. Now on the back of the board here, so we've just got those 2 mods there and the capacitor. The rest of this is just taken up with the contacts and the wiring there, little solenoid in the centre. And this is the sense coil here, and I see the wires just go straight through the centre, the neutral and line there. And that's on the incoming side, so of course that's where you would want it, so this would remain live all the time, and of course the other side will be totally disconnected. And if you look here, there's actually a 3rd wire, that black thin one there, going through the centre of the coil, and that actually comes across just underneath here where the test switch is, and you can see the contacts of the switch in there just pressed down onto the circuit board in a fairly bare sort of fashion. That's not going to be desperately reliable. And there's just a closer look in there, and you see it's just 2 prongs that come down onto the circuit board where there's a bit of solder inside there. And there's presumably one resistor somewhere, which is for the trimming function. It could be that one over there actually. And of course that's just passing a current, and it's actually going via this thin black wire, and the other end of the black wire is here, just connects over to that pad which next to it, and that green one then is the thin one that goes over to the earth on the metal front plate. So all that's being used for essentially is just a reference to ground, so if the socket wasn't actually connected to ground, the test button wouldn't work, so that's a good feature that would obviously tell you that something was wrong. But to say, I don't like the way it's just sort of stringing over there. They could have connected that to the earth's part internally rather than just having it flapping about loose like that. And I say that switch will probably work, just having metal prongs stabbing down onto the circuit board is certainly not going to be the most reliable arrangement. So look there, another RCD socket. This particular one you can use in the UK, and of course it is designed for use here, so not a problem there. It's got the correct shape outlet on the front with the shuttered holes and everything else. And although it is actually a pass on the test, it's certainly at the very lower end of the scale in terms of the tripping current. Normally for a 30 milliamp device, you would expect it to be in the high 20s, sort of 27 to 29 kind of range. Although I say as long as it's over 15 and less than 30, then of course that is considered a pass. We generally don't want devices to be in the sort of 17, 18 range, because of course that can lead to problems if you've got various devices plugged in with actual leakage current, such as switch mode power supplies. And of course the other issue is that if the value drifts somewhat over time or with temperature, it could end up being less than 15 in certain circumstances. So although there is a pass, it's certainly not really what you would want to see. And internally it's very similar to that Florion socket that I had a look at a few months ago. Again, that 8-pin chip pretty much does the whole thing, and the only other components there just for say a few resistors and a couple of capacitors. And the spark on the contacts is purely due because there's no suppression there whatsoever. The only real components in that line are those two MOVs, which are only there really as surge protection, primarily to protect the electronics, or at least go some way to doing so. So it's going to spark pretty much every time, and of course that will lead to the contacts wearing out fairly quickly, although you wouldn't expect it to be switched on off that often. And again, that test button is a bit dubious as well, with the there's just metal blades stabbing down onto the circuit board with no actual switch or proper switch mechanism in there. But again, it's not likely to be used or tested that often, so no doubt it does the job. But until next time, thanks for watching.